Hey everybody, this is a Herminator here. We are going to take this first assessment this coming Friday. And on the assessment, you're going to get to use this sheet. Make sure you're looking at the right list. You have your perfect squares, the perfect cubes, like 2 times 2 times 2 is 8. Therefore, 8's a perfect cube. Its cube root's 2. Perfect force, 81, so it's not 9, though. It's what times what times what times what's 81, and that'd be 3. Perfect fifths, okay. Perfect sixths, even. Usually we don't get into, well, we might, I don't know. You get this. There's also going to be a packet that we're going to do later in the week that I'm going to be okay if you use it as an open notes for the very simple fact that this Friday, that's kind of soon to be given our first test, but since we've done all this stuff, almost all of you, I can do that for you. So, let's go ahead and get started and see what this is all about. So, convert and ignore, I want to know what this thing equals, okay? So, the fourth root of 18, I want you to do that on your calculator, okay? So instead of 80 to the 4th power, since it's a 4th root, you take 80 to the 1/4 power. Okay? A root, you just reciprocate that into an exponent. So 1.68, good enough for me. I don't even care if you put the plus minus, you would, because it's a 4th root. It could be positive or negative when it's even. The cube root of 18, so all I do is make the 18 into an exponent, but I have to reciprocate that root, so it's a 1/3 power, okay? And that's going to be 2.62. Okay, pretty easy there. Now, on the next 4 problems, the next 4, we're going to be using this sheet to simplify. We're not just going to be punching it into the calculator. We can use a calculator, but it's more to it than just punching it in. Okay, so you notice how this is multiplication. It's a dot, and there's 3 steps to multiplying roots. First off, you say, are my roots the same kind of root? Yeah, they're both 4th roots. 5 4th root of 64 times 2 4th root of 8. Okay? They're both 4th roots, so we can go ahead and multiply. If they were different roots, you can't multiply. You can't do anything if the roots are different. Like if I have a cube root and a 5th root, I can't do anything with that, okay? So what I do is there's 3 steps to multiply. Here's step 1. You multiply your coefficients, your multipliers, 5 and 2. 5 times 2 is 10. And then you make your root, just one root, and put a little 4 in there so you know it's a 4th root. And you just take 64 times 8. 512. Okay, you're like, well, what do I do next? Well, I'm going to tell you. You drop your 10, and then you want to break this up. First off, go to your force, your perfect force, and make sure just that 512 is not actually one of the numbers. It's not, okay? 512 is nowhere to be found, okay? So if that's nowhere to be found, we drop the 10 and write times root, okay? And put little 4s in there so you know they're 4th roots, okay? Now, what I want to do is see if 512 divides by any of these perfect 4th numbers that I'm running my little naughty finger across, okay? So 512 would just start with 256. Oh, snap, I got 2. That's good, okay? So what number did I divide by? 256. Put that in first, and then put your quotient second. You need to do it in that order. Well, step 3, the reason you have this, you got to get rid of the 4th root of 256 because that's equal to an actual number, a solid number, solid integer, and it's 4. Okay? Then the last, I just multiplied 10 by 4. Now, those are both not in square roots, so it's 40 with a 4th root of 2. Put the little 4 in there at the end. Okay? Done. So multiply, remember it's a 4th, and then break that up using your little sheet. And there's a number that's going to pop out of there to multiply by 10. Okay, our next deal. Now we're not multiplying. Now we're adding, okay? Adding's a lot different than multiplying. They're not even comparable, so I'm not even going to try to compare them. With adding, you're going to make charts, and what we're trying to do on this chart is get the number inside the root so that it's the same. So I have 5. By the way, these roots, if you don't see the little number in, are a square root, so I'm going to put little 2's in there so we know. So 5, square root of 5. And then the other add-in is -4 square root 45. Okay, now there's 2 steps in here that we need to follow before we get our answer. First, I look and see I'm on my perfect squares now, so 5. I don't think 5 divides by any of that other than 1, which is irrelevant. Okay. So if I don't see that 5 is going to divide by anything, I mean, what I do is I drop my 5 times the roots. They're both square. But I see, oh, 5 isn't going to divide. So all I do is take this and write it down here. Okay, it stayed the same. It means it was prime. There's nothing I could do with that. Okay, now the next one, -4. And times your 2 roots. Put little dots so you know that means multiplication, and they're 2's. So 45. I think 45, 36, no, 25, no, 16, 9. It'll divide by 9 because I'm dividing by 9. And what's 45 divided by 9? It's 5. Now when that do that, we get rid of that, and we got to replace that. So that's 3. Okay. And now we take 3 times -4. That's -12 square root 5. Okay, now here's how you get your final answer. Don't stop there. You got the same square root with the same number inside, so just put that down. And then all you do is add the outside coefficients. 5 plus -12 is -7. Okay, so you got to know the difference between when you multiply and when you add. Okay, multiplying 1, 2, 3, adding's the chart with 2 steps to break it down. Now, next one's another adding one. It's going to be the same thing. I just want to put 2 of them for good practice. So I've got 2 root 4, 1,250. -8. 4th root, 32. Okay, so we want to get these, so these numbers in here have to match somehow, some way in order to add. They don't have to match when you multiply, but they have to match when you add because you can only add like terms. Okay, so 2 times root. Remember, they're 4th root, so we have to look at our perfect 4s. So 1,250 is the number, so I'd probably start here. That's higher than 1,250, so 625. I got 2, so what did I divide? You put 625 first and then 2. So 625 and 2. Then get rid of 625 because that has to be a number. That's why it's on the list, because that's equal to 5. And then we take 5 times 2. That's 10 with a 4th root of 2. Okay, and then number 1, -8. And those are 4th roots. Remember that. Okay. So 32, perfect force. Well, I think that divides by 16. 32 divided by 16 is 2. So 16 and 2. Get rid of that. And that's equal to 2. And now I can find the product of that 2 and -8. And that's -16, 4th root of 2. Okay, we got them to match. So I have a 4th root of 2. And then I add the multipliers, the coefficients. 10 and -16 will make -6. Okay, then simplify. Okay, again, simplify means we're using this sheet. As soon as I'm done with the simplify problems, I can put that sheet away. I'm not going to need that anymore. Okay, what happens when I have a root with a bunch of variables in it? Well, what we're going to do is break it up. So we have the number, the cubed root of x to the 7th, and the cubed root of y to the 9th. Okay, so 135, let's break that up. Remember, it's cubed roots and cubes. So 135 is going to divide by 1. No, there's no way. 64 maybe. Nope. 27, you got 5. Okay. So I have 27 and 5. Now you need to get rid of that. That's why you put those numbers in there, because that first one gets rid of it, and that's 3. Okay, just put a little 3 right there. So 3 cubed root 5. Okay, now you got to do some math in your head. You got to think, if I have 7 x's, how many groups of 3 can I create? I can create 2, so I put x second there. How many would I have left without a group? I'd have 1, so I just put x there. Okay, how about if I have 9, how many groups of 3? How many teams of 3 can you make? 3, so y to the 3rd. And do you have any left? I don't think you do, so don't even put a y in there. Now to make your whole answer, you put a 3 out and a 5 in. You put x squared out and x in. And then we're just going to put a y to the 3rd out. No y's would be inside. And then, of course, it's a cubed root, so we got to remember to put that little cube in there. Okay, that's simplifying. So on those we can put away. Okay, now it is time to solve some equations. And when you get to the solve the equations part, what I would recommend you do first is look for equations that have a square root in them. So I don't see any roots or just any kind of root. None there. None there. By the way, oh, how about here? Okay. First off, when I have a root, I'm thinking at the beginning there's just one answer. It might possibly turn to 2, but we'll just think of it. It may probably start with 1. What I would recommend you do is circle the root. It's a cubed root. Now, do you have anything outside of those circles? No, you don't. Okay, so that's good. So I can get rid of the roots now. We need to parenthesize each side, and if it's a 3rd root, we take both sides to the 3rd power. That's the opposite. Okay. To get rid of a root, you use that power. So get rid of that and get rid of that. They both cancel, and I have 4x minus 9 equals 2x minus 4. And I'm still thinking there's only one answer because nothing turned to a second power. So minus 2x, get your x's on one side. So 2x minus 9 equals negative 4. Then get your non-x's to the other side. So 2x equals 5. Divide by 2. You can just leave that 5 over 2, or you can put 2.5. Doesn't matter. Okay, more roots. Okay, I'm assuming there's just one answer. Circle your square root, but just the square root. Okay, remember that means it's a 2. Now this time we got some stuff outside we have to deal with. I have this plus 1, which I will subtract, and then I have this multiplier of 3, which I'll need to divide by. So all I do is minus 1, so I have 21. So I've got 3 with the square root of 4 minus 3x. Now this 3, we divide. That's 7. So I have the square root of 4 minus 3x equals 7. Well, now, when I circle that, I don't have anything outside, so I can get rid of the root. And I'm going to take both sides in to the second power. That side cancels, so on that side I'll have 4 minus 3x. Now on the other side doesn't cancel, unfortunately. We actually have to take 7 to the second power. That's just a power, so it's just 7 to the second power. That's 49. And then I can solve for x. I minus 4, so negative 3x is 15, is 45. Divide by negative 3. And x is negative 15. Okay. This is how I'm going to solve equations with roots. Okay, next one. Circle the root. It's a square root. Nothing outside. That's good. I don't have to do anything. Just now it's time to just get rid of the square root. Parenthesize both sides and take it to the power of 2. Opposite of a square root, it's a power of 2. So cancel them. That side will just have our 4x minus 1. But on the other side, it doesn't cancel. It's just a power. 4 to the second power is 16. Plus 1, 4x equals 17. Then I will divide by 4. And we can put 17 over 4 or 17 over 4 is a fine answer. You can leave it improper. Okay, my next problem. Start with one answer. So I circle my root. Is there anything outside of it? No, nothing there, nothing in back, so get rid of it. So second power, second. This side cancels. You have to determine the side that cancels where you can just copy down the expression. It's that side. That side doesn't. I wish it did, but it doesn't. There's no root. It's just a second power. But the problem is it's not just a number to the second power. It's a whole expression. So what you need to do is duplicate that and keep it minus. You keep the same sign. Do not make it plus. X minus 10, X minus 10. So x times x times negative 10, remember that's negative 10, negative 10 times x, and negative 10 times negative 10. So that's x squared, negative 10x, negative 10x, and 100. Why add those? No, they don't cancel. That makes negative 20x. So over here you need to put x squared minus 20x plus 100. Well, at this point in the problem, I can see we need to add a second answer because x squared. And I have x squared, and then I've got regular x, so I'm going to need to factor. Everything has to move to one side, but don't move the x squared because that's positive. That's where I want it. We'll move this crap over here. Okay, so it's going to give me 1x squared, negative 20 plus 2 is negative 18x, plus 56 equals 0. And then it's a trinomial, so GCF, there's not going to be one. And then it's my t-chart, okay? So 1 times 56 is positive 56, sum of 18, and that's 4 and 14. And a equals 1, so that's good. I just need the 2. Minus 18, so minus 14, minus 4. So x minus 4 equals 0, and x minus 14 equals 0. Plus 4, x equals 4. And 14, okay? So that's how you solve root equations. You just circle the root. If there's nothing out, if there's something outside, you might have to do some adding and subtracting and then dividing, and then get rid of your root, and then kind of go from there. Now, after you've solved the ones that have a root, go back to all the rest of them. You're done with the roots. And now, you're either going to use the Q or just use like terms, depending on if you have a parentheses or not. So there's 3 answers, because I have got powers with my x's. There's no parentheses here, and that's the only kind of x we have. So minus 40, minus 40. So I've got x to the third. 25 minus 40 is negative 15. How do you get, to get rid of a second power, you square root. To get rid of a third power, you do a cubed root. Now, that's a root, so you can't just put it to the third power. You have to take negative 15 to the 1/3 power. So negative 2.47. And that is an odd root, so there we don't do plus minus. Okay. If it's an even root, you got to put the plus minus, but it was odd, so I just got the one answer. Okay, next problem. I'm thinking a Q's probably in order, so I'm going to circle that. Put my 4 answers I think there are. And my chart here. Q to the fourth equals 256. Okay, fourth power, I think we need to do a fourth root. So Q. Now, a fourth root's even. So like a square root, we got to do plus minus. And then you don't just take that to the fourth power. To do 256, you take it to the 1/4 power. And that gave me 4. Okay. Now I make this chart because I got to keep going. So I could be equal to +4 or -4. Now, if there's no plus minus, we'll get into that in a bit. So bring in your x minus 5. Plus 5 plus 5, x is 9. Plus 5 plus 5, x is 1. Okay, don't need the others. Okay, next one. There, I don't need q, there's no parentheses, so we'll just divide by the 7. That's a fourth root, get rid of that. 4 is an even root, so we got to plus negative that. So I take 8 to the 1/4 power. If it's a root, you put the 1 over it. So 1.68. So 1.68 and negative 1.68 out of there. Okay, next one I believe calls for there's 5 answers, and I believe that will call for a Q. So Q to the 5th equals 362. So it's a 5th power. So I go with a 5th root. Make the root, make it a 5th root. Out of here. Now that's odd, so do not put plus or minus. And if you're not going to put plus minus, scribble that out or put no or something. Okay, there's no sense doing that. So 362 to the 1/5 power, 3.25. And bring back x plus 3. So minus 3 minus 3, x is 0.25. Some of you might be, well, with those square roots we started off with, would you use Q for those? I would recommend you not. I would only use Q with the parentheses. With square roots, I'd circle the square root and then add or subtract and divide. Because otherwise people are going to think they do the chart with those and you don't. Okay, because you're using powers. Next one, x to the 5/3. I don't need Q. It's not a parentheses. I'm going to put 5, because it's a 5th power. Then I divide by 2. Divide by 2. So x to the 5/3 equals negative 32. 3/5. 3/5. Now, I know you know how to punch that in on your calculator, but what I'm afraid you don't know is whether you need a plus or minus, because you see, 3 is a power and 5 is a root. That's what that means. 3 is the power, put a little power and root, or P and R. Well, the root's what I'm looking at, and it's odd. It's a 5th root, so no plus minus needed. I just take negative 32 to the power of 3/5. Gives me negative 8. Okay, so that's your only answer. Eliminate the rest. Okay, next one. Again, second power, and we have a whole parentheses, so we're going to use Q. And then we're going to add 3, so Q to the 2/3 equals 16. Now to get rid of a fraction power, you just flip the fraction over. 3/2, 3/2. Now my question to you is, do we need that plus minus? Because you see 3 is just a plain old power, but 2 is a root. So it's like a square root, so the plus minus is needed. So 16 to the 3/2 power is 64. So we need both sides. So 64, negative 64. And I put 2x plus 12. So minus 12, minus 12. And that is going to be 52 divided by 2. 52 divided by 2 is 26. And then negative 76 divided by 2, it's negative 38. Okay? We already did those because remember, you're doing the problems. The equations that have roots in them, do those first, and then come back and do your like terms and your Q stuff. Okay? Rationalize the expression. Here's what you need to do. First off, you're going to wrap that up in a parentheses and times by another one. Do you have a plus or minus sign in here? Do you? No. So you just times by the letter I. So that's going to be 6I to the second. Get the I to the second out of there, and you replace that with negative 1. Now find the product of 6 and negative 1. It's negative 6. That's your answer. How about this I problem? Do you have a plus or minus there? Yeah, you do. So what you have to do is switch it and use the same 2, and then it's a FOIL problem. So I take 3 times 3, 3 times negative 2i, 2i times 3. And some of you are probably thinking this is stupid. Why? It's just a trig prep. For kids taking trig, I have to prepare them for it. But I can't just say, you're taking trig, you have to do it, you're not. That's not fair. Okay, 9, negative 6i, positive 6i. So since I have a positive and negative, out. And then negative 4i squared, which we know is negative 1, which we know is positive 4. Now I just add 9 and 4, 13. Okay, now square roots. You have to rationalize those too because they're not perfect squares. So wrap it up. And kind of like the first one we did on this page, you have a plus or a minus. No, you don't. So you times by just one thing, and that thing is going to be the square root of 7. Okay, it's all you do. So how you multiply that? Well, the 2 doesn't really have anything outside here, so that will stay 2. If I had like and then 7 and 7 is 49, but it's square root of 49. What's the square root of 49 turns into the number 7. 2 times 7 is 14. Okay, next one. Wrap it up. Do you have a plus or a minus? That's the key question. You do. So that needs to be minus, and then 3 square root 5. Now, we have to FOIL here. And if we have to FOIL, these square roots need 1s as multipliers so I can see what the heck I'm multiplying. So write it out. 3 times 3. 3 times negative 1 square root 5. 1 square root 5 times 3. And 1 square root 5 times negative 1 square root 5. So this gives me 9, negative 3 square root 5, positive 3 square root 5, get out of here with that, and negative 1 square root, and 25. Now, 25 is a perfect square because it equals 5. So then I multiply those to get negative 5, and then add, you get 4. Okay, now, again, I'm going to let this be open notes on Friday because stuff like that is kind of hard to remember, but with your notes you'll see it, I would hope. Okay. All right, graphing square roots, pretty annoying problems. First, we're going to forget about that plus 4, so I'm going to rewrite a new problem without the plus 4. Square root of x, skip plus 4 and minus 3. Okay, now we'd only want perfect square numbers inside that square root. Okay, only perfect square numbers. Now, I have 0. That is a perfect square, believe it or not. And then 1, 4, 9. That's good enough. And I write stop because we can't be putting negatives in the square root. It's going to say domain error. Okay, that's a positive 1. That's a little speck mark. So I put 9 in, so negative 2 times 9, but we got to take it to the 1/2 power because that's how we tell our calculator it's a square root, then minus 3. So I got negative 9. And there is a pattern that forms, so after I do the 4, I'll know the rest. Negative 2, 4, we got to tell our calculator it's a square root. Listen to that. Minus 3 is negative 7, okay? And then negative 5, negative 3. Now we got to do the opposite of plus 4. You can't just plus 4 because otherwise, here's what's going to happen. If you add 4 to that, you're going to get 13. 13 plus 4 is 17. Well, that's not a good square root to have. I do the opposite and minus 4. So it'll be 5, 0, negative 3, and negative 4. Get out of here with these. Because now 5 plus 4 is 9, perfect square. 0 plus 4 is 4. 4 is a perfect square. Negative 3 plus 4 is 1. 1's a perfect square. Then 0 and so forth. Now, you want to graph this bottom point first. Because here's why. 1, 2, 3, 4. 1, 2, 3. Put a stop. I don't want to see an arrow there because the domain stops here. Negative 3, negative 5. Sorry about the crappy graph paper. That's pretty crappy. 1, 2, 3, 4, 5. 0, negative 7. 1, 2, 3, 4, 5, 6, 7. 5, negative 9. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you connect them, and you do put an arrow on this end because all that does is take me into x's, because here's my x. That just takes me further into the positives for x, and I can put all the positives I want in square roots. I just can't have them be negative, and anything to the left of this point is going to give me negatives. That won't work. Okay, we'll do another graph. Y equals 4 times square root of x. Well, I'm good with that. There's nothing else in the square root with my x. 0, 1, 4, 9. You got to do that. If you're good at mental math, the square root of 9 is 3 times 4 is 12. Square root of 4 is 2 times 4 is 8, and then 4 and 0. But if you're not, put 9 in, take it to the 1/2 power. Can't emphasize that enough. That's 12. With roots, you reciprocate what kind of root it is into a power. 4 times 4, 4 to the 1/2 power is 8. Okay, we don't need to change anything because there was no adding or subtracting that needed to be canceled. I do need to see the stop sign right there. So 0, 0, stop. Okay, we'll count by 2's on the Y. So 1, 2, 4. 4, 6, 8, 9, 12. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then go up 2, 4, 6, 8, 10, 12. Okay, all right. Okay, we got 3 more days to go over this. It's going to get boring. And again, you need to keep your root sheet on you. Don't lose that. And then there'll be another packet later in the week that you can use on your test for open notes. Something I don't do often, but since first one. And this test, a lot of people have done crappy on. So maybe having the open notes will help.